Good evening, everybody.
Or good afternoon.
Okay, guys, this is going to have to be a little bit interactive. So if you don't mind me seeing you, or I'd like to hear you, I'll fix my hair in the meantime. Okay, don't worry. I'm not going to run through all my code and all that stuff. It's just going to be headlines, just to tell you what I've done. Milamala. First of all, I want to thank the Ratners for putting together such a wonderful course with wonderful people, and thank Leo very, very much for giving us your time and giving us of your knowledge. And I hope you're getting nachas from what we're creating based on everything that you've taught us. Okay, so I'm going to start asking questions, and you guys, thanks, Rafael. That's the last chat message I'm going to look at. The rest of you, just say it out loud. I like hearing your voices. Okay, so okay, this is interactive. Okay, does it interest any of you guys to be able, just with like 1 or 2 lines, if you have a Mac, if you have an IP address for a host on your network, to get the MAC address? Would that be cool to do?
Yes.
Yeah, very cool.
Okay, so this is actually one of the reasons why I chose this project, was because I have a fascination between when something physical meets something logical, or something that you think about. Like the brain, it's like a physical organ. It's a physical organ, but it like does these like things that aren't so physical, So that's also like where the physical and the non-physical or logical part of the computer, of the network, of the system meet. That's like where the MAC address and the IP address have their like interplay, So everybody has like their fingerprint. It's like from their physical body, but then they also have a name, which may have, higher meanings. So you have your IP address, that's like a higher name, and then you have the MAC address per device. So that very much interests me, which is what brought me to do this project, which I'm getting to soon. My next question to you guys is: would it interest any of you guys to make your own packet? We saw Wireshark and sniffing tools and stuff like that, and
me.
Yeah, that's it. Oh, come on in, yeah.
Happy.
So we see like we see these things coming in and they're flying all over the place. Like, okay, but like if I can really make my own one, so that'll give me like a hands-on understanding what's going on. So that was also part of my project. Who would like to then be able to manipulate the packet? If you're making one and you can send one along, down the network to the places you want to send it, manipulating those packets and causing some trickery will then be on our fingertips. Okay. Last question is, what about, we can use Wireshark, but maybe we can just make our own sniffer and collect all the packets that are going through the network adapter or the NIC, or whatever we connect it to, if it's virtual or if it's physical. Okay, that's also cool.
You want a better one?
What's that?
I said, because you want a better one.
You want a better one? Okay, so there's another thing that I did with it was included in this is now that you have a whole bunch of packets. Let's say I did a sniff. Well, let's say you did one. Let's say you got access to a network somehow. Somebody left their workstation open, or you managed to use one of the ingenious plans of the people from Tomet to actually get onto the network. So now you're on the network, and now you're sniffing. You're sniffing somebody's connection. So, you know, you got a whole bunch of their packets. So now what do you do with that? Like, it's like, you know, it's like spaghetti bolognese. Like, it's just like all mixed up stuff. You got these piles and piles of things. Like, how do you make sense of it? And also there's like there's thousands and thousands of different packets that's not even Nogueira to you. So Leo showed us how to filter out the packets to see, you know, what's Nogueira, what's applicable, what we're interested in. But let's say we get a whole stream. Like, can we use that whole bunch of stuff to create some information from it, not just, you know, raw data packets? Okay, so I'm not going to go into my code. That's basically my presentation. If you're interested in some of the code, I wasn't planning on speaking tonight, but I just made some. I'll share my screen. I'm not going to show you the code. Don't worry. I'm just going to show you how easy it is. It sounds so cool, and it sounds so maybe sounds a bit difficult, but it really isn't, because with this Python baby, things are like that's simplified crazy, and I'll just show you how. Now everybody's face is in my way, so I'm just going to look at myself. Okay, here's the first one. This is what we spoke about, is how about getting a MAC address from, you know, using an IP address. So here it is. Here's a straightforward function. You can see my screen, right?
Yes.
Yes.
Okay, so here you go. Here's making your own packet. We spoke about it. How cool would it to make your own packet? So using one of Python's libraries, okay, yeah, you make an Ethernet packet, a layer 2 packet. You tell it your destination. Yeah, I happen to put in the broadcast address, and I made an ARP request, okay, using somebody's IP address. So I have somebody's IP address. Let me do this. Okay, whatever. I have somebody's IP address. I want their MAC address. So that's it. I now created my own packet. I'm sending it to everybody. The destination address is everybody, and I'm asking who in the whole network, please tell me who has this IP address. Give me your MAC address. Okay, that's it. That's it. It's making your own packet. Now you want to just send it. Okay, so let's call a send and receive method from one of the Python's classes, and that's it. You just send and receive it, and you put the answer in some variable, and then you've sent your own packet along the network. So, you know, like, I find it fascinating. It's fascinating how high level Python is, that just with a couple of lines, you can really do cool stuff. Okay, and here we get, this is the main answer. When we send our packet, we get the Ethernet component of the response, and we want the source attribute, and that's the MAC address. Okay, so that's as easy as that. Now, if you probably could guess that my objective with all of this is that I wanted to create an ARP poisoning. So I have a Windows 7 machine, and I have a router. The Windows 7 machine is communicating with a router to get images from a taxonomy website, because that's the only one I could find that's HTTP. Basically, everything has been changed to HTTPS. So because I'm going to want to extract information from those packets, it can't be encrypted. So I found this HTTP site, and I wanted to now put my ear to the wire and hear everything that this Windows 7 machine is requesting from the router, which is then going to get the information from this taxonomy site. So how did I do that? That's the ARP poisoning, like Leo taught us. I told the Windows 7 machine, me being the Kali attacking machine, that I've gained access to the network. So I told the Windows 7 machine, listen, Windows 7, you want to speak to the router, which is at .8.1. That's the gateway, .8.198, 192.168.8.1. You want to speak to him? I'll tell you, his MAC address is mine. And I give Windows 7 machine my MAC address, and that's the ARP poisoning. And then I say to the router the same thing. I say, hey, router, you want to speak? You want to send stuff to the Windows 7 machine? Well, you can do that. We both know his IP address, but then I sneak in and I poison, so to speak, I switch in the ARP cache. I switch the MAC address that it already knew the MAC address for the Windows 7 machine, but I go and I switch that MAC address and give the router my MAC address instead of the Windows 7 machine's real physical address. Okay, so this was the first. Well, okay, where are we? Let me get you back on my thing. I thought it would be just 5 minutes. How long have I been going for? I'm enjoying this. Okay, so this is just getting the MAC address. Now, once we can do that, now we're going to poison, like I explained. We're going to poison. It's also, just look at the green lines. All the stuff in between is just like semantics, you know, just like things that you need just to get the programming working. But the real brains and the real cool stuff behind it is this poison, to poison the victim, which is our Windows 7 machine. So we're just creating an ARP request, okay? That's what it looks like. It's an empty ARP request. And we're going to now take this and we're going to give it different properties, different attributes. So the ARP address, the ARP packet is going to have this source, and we give it the gateway. It's going to have this destination. The packet's going to have this destination, and we give it the victim's address. And we're going to give it now the victim's MAC address. I don't even remember how it goes. And then finally, we just send the packet. We send the packet. And here's the packet that we created, right? Here are the attributes of the packet that we set here, the source, destination, and the hardware destination. And then we just send it. And that poisons it because we decided to switch the MAC addresses. Okay, so that's that point. And then we discussed, okay, so that's like the main thing. And then, you know, I asked you, like, what about making our own sniffer? Because now, while this is happening, I can go to like Wireshark and then start to sniff it. But if it's all in one program, it will just sniff exactly what I want it to. So here you can see I've set it to run. This poisoning will run for 45 seconds. I could do it for as long as I want. But this is when my testing. I don't want to wait. You know, each time I do a test, I wait like 3 minutes, whatever. So I made it for 45 seconds. But what's also cool about it is this loop. This was quite a cool thing. This is outside the loop already. But this loop is that every you can see every couple of seconds, sleep 2. Every 2 seconds, I remind the Windows 7 machine that the MAC address for the router is me. And I remind the router every 2 seconds that the MAC address for the Windows 7 machine is me. So that's this loop, and it just goes, it keeps going every 2 seconds. It reminds them, hey, you want the MAC address for that guy?
Sorry, can I interrupt?
No.
How
Yes, you
dare
can
you?
interrupt. I hope I can answer your question.
Why do you need to remind that? Why do you need to send?
Because ordinarily what happens, and actually when I had my Windows server, my domain controller on the same thing, on the same network, so suddenly like it starts to wake up, and then it starts to ask, hey, like where's he sends an ARP request, like where's really the MAC address? And I didn't think I was going to present that because I didn't have this in time, but I did make a video of the code and all that stuff and of Wireshark. And there's an interesting thing that Wireshark picks up and highlights in yellow in the packet. It highlights and says, did you know that this IP address is associated with 2 different physical addresses? For example, in other words, it was saying like Windows 7 has its real MAC address, but the router thinks that Windows 7 has a different MAC address. That means Wireshark is picking up that the Windows 7 IP address has two MAC addresses, its own, its real one, and also the one that the router thinks it has. Okay, so does that answer your question? There seems to be a necessity to keep reminding, otherwise it's going to will reconfigure itself.
So basically, in order that it doesn't question.
Question and reconfigure.
Thank you.
Okay. Also, like if you look at a packet capture, I'm still answering your question, Esther. Also, if you look at a packet capture, like every now and then, for some reason, these ARP requests, and I think I don't know how much. I don't know the theory of how it's set, but it apparently the devices on the network keep refreshing themselves. It's probably like I guess it's like DHCP that it has a lease, so the ARP also has something like that. Okay, and lastly, just to make your own sniffer, also it's just like one line. Check it this. It's just one line. Make it here sniff, sniff, and it's a function. You just put like a few parameters, which isn't really so important. I mean, important meaning it's functional, but you can just look it up what they mean. So here you make your own filter. So I wanted the filter to be specifically TCP, the TCP packets, and of this IP address from the victim. And so that's here. That's this. That's the Berkeley packet filter. You can look it up. It's quite interesting how they came up with it. And that's it. You sniff it, and there you have your own sniffer. It's like, well, this Python is like crazy. It just makes everything like just, you know, it's such. That's what they mean by a high level language. It's high level. You like say it's like Mishnah. So it's like like Tertiary B'Ksav, like you have like one phrase, and then like you have like these mountains and mountains of Meforshim, and you know, all the way down the generations, and that's what it's like. Like Python's a high level. You say like one function, and then there's like so many ramifications in so many different libraries, which is also high level, and then it goes down at the next layer, and the next layer, and the next layer, and the next layer, and the next layer. So I'm grateful that that Python has been made a cool thing in this course. And then was just interesting here. You write it to your own PCAP file. That's it. Yeah, WR means write. PCAP. Write it to a PCAP file. Give it your own name. I called it Mr. ARPA, YP. That's your advisor. And you send it all the packets that you gathered with the sniffing function. That's that. There was just that one other thing. I don't want to hold up too much. But I'll just mention Milmala that the other thing that I started to do was, once I have all these packets and all this raw data, now what do you do with it? So I specifically wanted to go through the packets and find all images that the Windows 7 computer was getting from this taxonomy website. And so that's quite involved. It was more than I thought it would be. It required me to recommend this. When you're debugging, it's always good to actually print it on paper, you know, highlight your function calls, who's calling what, and it kind of gets you out of the mumble jumble. And so basically it was, you know, getting the packets that we want from the PCAP file, chopping off the headers, or identifying which packets we want via the headers, then chopping the headers off, and then gluing all the contents together. But before that, you need to unzip it, because usually it's got this gzip compression, so that when you're sending things over the network, it's much smaller. So you've got to decode that, then glue the packets together. That's already been chopped off the engine and the caboose, you know, like the trains, the header, and they're not trailers, but the headers, and stick it together, and then come out with your image from all these packets. Thank you for listening. It
was our pleasure, Rita.
Sorry?
I said it was our pleasure.
Oh, good. Thank you very much. I'll not take any more questions, and I'd like to hear the next speaker. Call to.
This